We live in a world that's actually uncommon for what goes on routinely in the universe. If you go to the center of the sun, for example, I don't recommend this, but if you went to the center of the sun and you managed to not get vaporized, you would find that the light that is passing your head, it's primarily X-rays, a little bit of gamma rays, it's mostly X-rays. There's other light too, but it's dominated by X-rays. X-rays is just another band of light. Isaac Newton didn't know that. He didn't know everything. All right? The whole spectrum. We have Roy G. Biv on the other side of the V. We have ultraviolet, invisible to our eyes. We can detect it though. You detect it by, you detect it by your sunburn. You detect it a little too late. See, it's a time delay there. And then you really detect it with skin cancer. See, so you want to, beyond ultraviolet, you have X-rays, and that we can't detect those either, and then gamma rays. You could eventually detect these, but again, we detect them with cancers and things. It's not an effective way to detect it. Go to the other side of red, we find infrared. Can't see that either. Beyond that, we have microwaves, and then radio waves. All of it is light. It all travels at the speed of light. So if you go into the sun, here are these X-rays. They have such energy. These are photons of light. They have so much energy. Energy goes up with violet, ultraviolet, X-rays, gamma rays. It goes up. It goes down in the other direction. It has so much energy that you can ask, what happens if you plug that energy into the equation E equals mc squared? Just do that. If that's the energy on the left, what mass equivalent is that? And you know what you find out? It has so much energy, it could spontaneously make matter. It can make a pair of electrons on its own. So in the center of the sun, matter is being forged out of the soup of energy every moment of the sun's life. Now, what kind of matter does it make? It makes an electron and an anti-electron, a positron. Matter and antimatter pair. Antimatter is real. We invented it, not the science fiction writers. I know they've taken command of it, but it's our idea. We got to get credit when we can, because the science fiction writers can be so good at this. So when you have a high enough energy for the light, it will spontaneously become matter, and the matter-antimatter pair come back together. It makes the X-rays again. It's a soup. That's unfamiliar to us. We don't see that. Visible light doesn't do that. It's not energetic enough. It just stays as light or gets absorbed, but doesn't become energy. It doesn't become particles. All right? In the early universe, this went on big time. Big time. And it's one of the symmetry laws of particle physics that light becomes two particles, matter and antimatter. You bring them together, they become light again. It's always symmetric. Always. Yet, we're made of matter. Where's the antimatter? So there's some discussions that if an alien came and landed from another galaxy, before you shake its hand, or whatever appendage it's offering you, flip it a coin. If the alien spontaneously explodes, it's antimatter. Just always be ready to have something else touch the alien. So antimatter are perfect counterparts to matter. So something happened in the early universe to create an asymmetry. It's one of the mysteries of the early universe. 1 out of 100 million of these particle-antiparticle pairs, 1 out of 100 million of them was just a particle and not the antiparticle. 100 million. I mean, it's rare, but it happened enough to account for all the matter that we know and see and love in the universe. There's no reason to think that if it happened the other way, that we would just be antimatter talking about matter aliens, flipping them an antimatter penny. But then they probably wouldn't call themselves anti-anything, right? So yes, it's one of the great mysteries in the early universe, how it came to be that there's an asymmetry in this very symmetric process that we see all the time. So that's a long answer, but you get the full context of that. And it affects the Big Bang as well as what's going on in the center of the sun. And technically it would be called symmetry breaking, more broadly. You can Google wiki symmetry breaking, and they talk about the laws of physics that are broken by some phenomenon or process in the early universe. Who's got the microphone?
Question over here.
Oh, you have to be more triangulating
I'm
on
still
ear.
right
There we
here.
go. Thank you.
I hope this isn't too off topic. Sorry.
This is the universe. How
Well,
could it
okay,
possibly
this is in the
be off
universe.
topic?
Then this is in the universe because
As long
I don't
as
know
it's
when
in the universe.
I don't know when I'll have an astrophysicist to ask this
Okay.
of again. So in light of current events involving the BP oil spill, and
Oh, by the
something
way,
that I read in the
by the way,
yeah.
everyone blames BP, but it's our oil spill.
The oil spill that's
We all
currently a
use
disaster
oil.
in our world
We
right
all
now.
fill our cars.
Okay.
We are collectively.
Without a doubt.
Okay.
So, in light of that, and something that I read in the Times on Sunday saying that we know more about deep space than we do about the deep sea,
Indeed.
would you suggest that perhaps we should spend more time studying things that we don't know in our world? And as an astrophysicist, can you suggest anything that might be done that they are not trying?
Okay, so there are two questions there. How do we help BP fix the problem? And should we spend more money on Earth than in space? But you link them into the same question. That's awesome that you managed to do that. I only had one suggestion for BP, and I tweeted this a couple of days ago. I said, what's all this effort trying to plug the hole? It's coming out of the ground. Ultimately, that's what we want the oil to do anyway, right? Why don't we put another pipe and fill a barge with it? So I just tweeted that because it seemed to me to be easier. Then I later learned that they tried that, but that failed. But that's got to be easier than trying to stop the leak. Can't you just put a thing, just okay, and I got it coming here. I mean, you do this as a kid, right? You put pieces of things together, and you finally get one, you put it in a barge. We need the oil later on anyway. We probably need it right now, all right? So I don't understand why that wasn't the first thought. One of my concerns about this failure is that it's actually an engineering failure. And if you create a world absent of engineers, because all the smart people who would have become engineers had no grand plans to go into as a job, in the 1960s, we were going to the moon. Even though it was a militarily driven enterprise, it attracted scientists, engineers, mathematicians to want to become those fields. When there's a disaster that happens, I don't want people saying, oh, we plug it with golf balls. Like, what kind of solution is that? Like, where is the genius that we know the human mind is capable of? Well, I think they all became investment bankers or lawyers. They're not scientists and engineers. So the fewer scientists and engineers in your midst, the more susceptible you are to the failure of your infrastructure, because you don't have people thinking about how to prevent it in the first place. For example, the day we find the asteroid is coming. Oh, by the way, there is one coming. If there's time, we'll get to it. But, okay. But just if there's time, I don't know, we might. So, so the asteroid's coming. Most people, you know what they'll do? They'll say, run! Stockpile food! You know, they'll say, okay, that's not who I want sitting next to me. The person I want next to me saying, how can we deflect that? That's a different brain. That's a brain that sees a natural disaster as a problem to be solved, not as a disaster to run away from. And if you don't have engineers, no one is thinking that. Nobody. They're just thinking how to run away from the problem. That's a problem in our modern society. So now, getting back to spending money on Earth and not in space. That's a common criticism of NASA, actually. Why are we spending money up there when we got perfectly good problems down here to solve? And I hear that. It's not that I don't hear that question, but it's missing some context. Some context. For example, did you know that global climate change did not exist as an understood problem on Earth until we studied the effects, when I say we, I mean not me, we, the community, studied the effects of the asteroid impact that took out the dinosaurs 65 million years ago. There's a whole portfolio of reasons everybody's giving for what killed the dinosaurs. Then we find a 200-mile diameter crater off the Yucatan Peninsula in what is now Mexico, dated to 65 million years ago when all the dinosaurs croaked. I'm saying we got an asteroid took out the dinosaurs. You're going to talk about it was cold or they had a virus. I got an asteroid, okay? So that forced people to ask, well, if you weren't in the 200-mile diameter, where we know you're toast, how might you have died around the Earth? So you look at the fires that would have been created. You look at the Earth's crust cast into the atmosphere. You notice that it cloaks Earth, blocking sunlight from reaching the photosynthetic plants. If you take out the base of the food chain, then a wave of extinction percolates across the tree of life. We learned about this, and this forced the climate models to understand global climate in a way no one ever had the occasion to think of before. That's when it was born. Not because somebody was looking down, I got the solution here, I'm looking down, I'll figure it out. No, sometimes you have to look up. Do you know that planet-wide greenhouse effect was first discovered on Venus? Venus has a really bad greenhouse effect. It's 900 degrees Fahrenheit on Venus. And I did the math. You could cook. You okay over there? Okay. Sound like she was planning to visit Venus, and now she's got to cancel the vacation plans. Venus has saw it. You could take a 16-inch pepperoni pizza, put it on the windowsill, and it will cook in 9 seconds. Okay? That's hot. You would vaporize as well. So this is a thought experiment. If you could do this, so global greenhouse effect. It was understood there before we could then bring it to Earth. Earth is not some island in the middle of nowhere. It is connected to the cosmos. And no science can claim an understanding of its subject if its subject is numbered only one. You need multiple objects to compare and contrast. That's how you learn what is special, what is not special, what is real, what the phenomena are. And so to say, let's only spend the money here, that's suicide. Not only that, how much does NASA get? I've done this experiment. I ask people, those that say, well, we're spending, these people, okay? I ask, well, how much do you think NASA's getting? Here's your tax dollar, pull out $1. Here's your tax dollar. How much are they getting? Okay? And here we go. Got my dollar. Oops, that's a 5. Wait a minute. Oops, that's another 5. There we go. Dollar. Tax dollar. How much? Here's your tax dollar. Is it 10 cents, 20 cents, 30 cents? How much is NASA getting? It is getting 1/2 of 1 penny of this tax dollar. 1/200th. That's not even, you're not even in the ink yet. Here, you're in the edge. That pays for the rovers, the space station, the space shuttles, the Hubble telescope, all the NASA centers, NASA headquarters, all of that. And I ask you, how much is the universe worth to you? Okay. Let's get a question from the Twitterverse. Where's my Twitterverse list?
We've got a Twitter question over here.
You can pick the question.
Oh!
She put an in front of every Twitter question.
I'm joking, Dr. Tyson.
Mm-hmm.
So a tweet from Focal Matter. When will
Focal Matter?
Focal Matter.
That sounds like a geek tweet is coming right there.
When will mankind see interplanetary travel?
That sounds like a deeper question than it actually is. I mean, when are we going to Mars? That's what that is. Unless you meant interstellar travel.
Interplanetary.
Interplanetary. We're not going to Venus. All right? I ain't going. If you're going, you ain't coming back. All right? It's one of those one-way trips. Mars is the only other sensible planet we could possibly visit. And in the current NASA budget, which is actually increased from previous years under the Obama administration, it has plans to develop what we call heavy lift vehicles. Heavy lift would enable you to not only reach orbit, as current launch vehicles do, but to go beyond low Earth orbit like we did back in 1972. And those vehicles, you'd be able to scale them in such a way so that they would get us to Mars, beyond the moon onto Mars. If that all goes well, surely before mid-century. And one of my concerns, however, is the motivation for going into space. If it's not clearly defined, it may never happen. In the 1960s, we told ourselves we're discoverers, we're Americans, we explore. Meanwhile, the subtext was we're at war with the commies, right? And it was like, beat the commies to space, right? That's really what that flow of monies was doing. And so if we want to go to Mars, I don't believe the nation can rally around the simple quest to explore. The history of human civilization does not support that. But what does support is the urge to get rich. So we find like oil on Mars. We'll be there like next week. Where we find rockets will be there. So I'd say by 2050. Another question. We got to go where the microphones are.
The other
Okay.
side? This side of the room? Crater side?
This, I need more. Crater side. Thank you. Yes. Where are we?
At your Beyond Belief 2006 lecture, you said that...
Were you there, or did you watch the YouTube?
I watched the YouTube.
Okay.
You said that what stopped Middle Eastern scientific progress was a theological takeover.
Yes.
Do you think that's happening?
That's a shorthand for what I said, but yeah,
Do you
I
think-
built the case a little more elegantly than that.
It was much nicer, yes. Do you think that's happening here in light of what's happening with like scientific textbooks in Texas and things like that?
Yeah, I just read recently about the plight of textbooks in Texas. I spent some time in Texas, 6 years actually, and of course Texas has Johnson Space Center. These are the folks who track everything we put in orbit with humans on it after it passes the launch tower in Cape Canaveral. All command goes over to Houston. So Texas is a fundamental part of our space enterprise, culturally and historically. So that for them to now have textbooks where the science content is altered to be different from what is going on in mainstream science worries me greatly. What you're referring to in the talk that I gave at that lecture is in San Diego, 2006. It referenced what was going on 1,000 years ago. 1,000 years ago, the intellectual center of the world was Baghdad. Baghdad. Europe was busy disemboweling heretics at the time. Baghdad was open to all thought at the time, between AD 800 and 1100, around there. If you look at the advances that unfolded in that period, in that location, it includes the invention of algebra. Algebra is an Arabic word. Algorithm is an Arabic word. 2/3 of the stars in the night sky that have names have Arabic names. How does that happen? Where did the naming rights come from? It came from the fact that at that time, huge advances in the Middle East, in Baghdad in particular, was unfolded in engineering, mathematics, especially mathematics, astronomy, navigation, physiology. And you say, well, why is that so? If you look at what was going on, they were open to all lines of thought. Jews, Muslims, Christians. There were doubters back then. Today we would call them atheists. They would all come around a table and share ideas. If you have some philosophy that's got holes in it, someone's going to find it. And you're going to challenge you on those ideas. And what happens is the conversation ratchets up. You discard what doesn't work and you keep what does. And when you do that, you make discoveries, and you make discoveries rapidly. And at the time, that period drew to a close. If you read history books, they'll typically describe sort of the sacking of Baghdad. It was a bad time for the city. And they say, oh, it all came to an end. However, the Islamic culture rose at other times later. And in those other times, science and engineering discoveries were not a part of it. So he asked, why not? You got the cultural heritage. Why doesn't it show up again? And then you got to dig a little deeper from the sacking of Baghdad, and you find out there was a Muslim cleric, Al-Ghazali was his name, who was to Islam what St. Augustine was to Christianity. St. Augustine kind of laid out the rules for how to be a good Christian at the time. A lot of people were practicing it in their own way. He codified it. He was a religious scholar, figured it out according to his own read, told everybody how to behave. There's the book. You follow this, you're a good Christian. Al-Ghazali said, you follow this, you're a good Muslim. In that text included the assertion, which gained influence socially, but then politically, so then it had power of influence. In there was the assertion that mathematics and the manipulation of numbers was the work of the devil. The entire enterprise collapsed and never recovered. It has not recovered since. If you look at the number of Muslims who have won the Nobel Prize in the sciences, it's 1. Number of Jews who have won the Nobel Prize, 1/4 of all Nobel Prizes in science have been won by Jews. How many Muslims in the world? 1.3 billion. How many Jews in the world? 15 million tops. So you look at what effect the culture of discovery and learning can have on what you discover about the natural world. It's extraordinary. So just because you're making discoveries doesn't mean it's forever. And I look at the 20th century in America as a period of great discovery. And then I see forces now operating against it. And then I look at the history of the consequences of this, and I see America just simply fading into insignificance. No, it's not off of a cliff. It's just a slope. And every next day you're a little bit further down on the slope. You barely notice it, right? Until one day you can't see over the hill that you just came from. And then you try to make do with what you have down here, and then you find out it's the rest of the world making the inventions and not you. You're trailing, no longer leading. You're not even abreast with what's going on. You're running behind trying to catch up.